Software engineers are, well, they're spending less time writing code than ever before, yet they're building complete enterprise applications in literally a matter of 72 hours.
Yeah, it's honestly wild.
Welcome to today's deep dive. We've got a really fascinating stack of sources for you today, primarily focused on Anthropic's 2026 Agentic Coding Trends report.
Right, which is a massive one.
It really is. And our mission for you on this deep dive is to explore this tectonic shift in how software is made. We are moving away from humans painstakingly typing out lines of syntax and toward a reality where humans set the strategy while autonomous AI teams handle the execution. So, okay, let's unpack this.
Well, we are formally entering what the industry is calling the vibe coding era.
Vibe coding.
Yeah, vibe coding.
Yeah.
And I know while that term sounds like a very casual, almost dismissive cultural mood, the data in this report outlines exactly what it means in practice. The whole development paradigm has just flipped.
Meaning we don't type, we just direct.
Exactly. Human expertise is now focused on defining the problems. We provide the context, we outline the edge cases, and we set the logical constraints in plain English.
Right.
Meanwhile, the AI takes on the tactical, granular work of actual implementation.
To really understand how this mechanical shift works, we kind of have to look at what is happening to the role of the traditional software engineer. Because, the knee-jerk reaction when you hear that AI is doing the coding is to assume the engineering department is just being hollowed out.
Right, which is a completely natural assumption, but it's really not what the data reflects at all. Engineers aren't being replaced. Their function is just, being elevated.
Okay, how so? Like, what does that actually mean?
Well, the software development lifecycle, so the time it takes to go from a conceptual idea to a fully shipped product that has collapsed from weeks to hours.
Wow.
Because of this compression, developers are becoming what the industry calls full-stack orchestrators.
Okay, let's break that term down for a second. Because full stack usually means someone who can build everything from, like, the database on the back end to the user interface on the front end.
Right.
But traditionally, mastering all those different languages and systems is incredibly rare. It takes years.
Precisely. In the past, you had a database specialist, you had a security specialist, a front-end designer. You needed a whole team.
Yeah.
But now, areas where a single engineer might have previously lacked specialized expertise, well, those are fully accessible because the AI fills in those technical knowledge gaps on demand.
So they just manage the whole stack themselves.
Exactly. The human provides the architectural logic, and the AI translates that logic into the specific syntax required for the database, and then into the specific syntax required for the user interface.
I understand the speed aspect, but I have to press you on the reality of this. Let's talk about the dreaded 3 a.m. server crash.
Oh, the classic scenario.
Right. If I'm the orchestrator and an AI built the foundation of my code base, say, 3 months ago, and suddenly the whole system just completely goes down,
Yeah.
if I didn't write that code line by line, how on earth do I fix it? Am I just flying completely blind?
Well, it's a highly logical concern. You would think delegating the code generation means losing your intimate understanding of the system.
Yeah, that's what you'd assume.
But the report highlights that the reality is actually the opposite. Because AI isn't just used for writing code, it's used for comprehending it.
Oh, interesting.
Yeah, take the example of Augment Code from the data. They build AI-powered development tools for incredibly complex legacy systems, things like massive networking platforms.
The kinds of systems that are just an absolute nightmare to learn if you didn't build them originally.
Exactly, the spaghetti code.
Yeah.
One of their enterprise customers had this massive project that the CTO estimated would take 4 to 8 months just to complete the background research and implementation.
Wow, 4 to 8 months.
Right. But by using AI to provide contextual code-based understanding, basically asking the AI to trace the dependencies and explain how the legacy systems interacted, a developer finished that exact project in just 2 weeks.
Just 2 weeks? Wait, because they use the AI as a translator for the old code?
Yes. It expedites onboarding from months to hours. You don't need to spend half a year reading outdated documentation to understand the quirks of a specific system.
Right, the AI just reads the system in seconds and explains it to you.
Exactly. And this is unlocking what organizations are calling surge staffing. You can instantly surge engineers onto specific critical challenges without that traditional months-long productivity dip.
Because they aren't stuck just trying to figure out how the machine works.
Exactly.
But wait, if an AI is reading entire legacy systems in seconds and generating cross-platform code simultaneously, we really need to talk about the mechanics here.
Yeah, the underlying tech.
Right. How is the AI structurally capable of not just choking on all that data?
And that brings us to the most crucial technical data point in the entire Anthropic report. It's the evolution from single-agent to multi-agent architectures.
Yeah.
This is the underlying structural shift that makes vibe coding mechanically possible. Historically, and by historically, I mean literally just a year or two ago, we relied on single-agent workflows.
Right. ChatGPT, that kind of thing.
Exactly.
Yeah.
A single AI processed tasks sequentially. It was completely linear. It would read a prompt, write some code, evaluate it, and output a result.
And the bottleneck there was the context window, right?
Yeah.
I always think of a context window like a worker's physical desk. In the past, the AI's desk was tiny. It could only hold a few pages of code at a time.
That is a perfect way to visualize it.
And if you asked it to review a massive application, things started falling off the edges of the desk, and the AI simply forgot what it was doing or lost track of the variables.
Exactly. The single agent was fast, but it could only process what fit on that desk. Now, organizations are moving to parallel multi-agent architectures.
Okay, so expanding the desk.
To stick with your physical space metaphors, imagine moving from a single worker at a small desk to an entire kitchen brigade.
Okay, a kitchen brigade. I like that. Let's map that out.
So in this setup, you have a central orchestrator AI. Think of it as the executive chef. The orchestrator doesn't actually chop the onions or sear the meat.
It just coordinates everything.
Right, it coordinates specialized sub-agents that are all working simultaneously. You have a database agent, a security agent, a user interface agent.
Oh, I see.
And each sub-agent has its own dedicated context window, so its own cutting board, essentially. They do their specific tasks in parallel, and then the orchestrator synthesizes all their separate results into one integrated output.
But how does the executive chef actually synthesize the work without causing a massive disaster? Like, what if the security agent's code completely conflicts with the user interface agent's code?
Well, that is where the orchestration logic really comes in. The central co-pilot acts as a quality assurance gate.
Oh, so it checks the work before it's done?
Exactly. It evaluates the outputs from all the sub-agents against the original plain English constraints you provided. If the security agent flags a vulnerability in what the interface agent built, the orchestrator halts the compilation.
And makes them redo it.
Yes, it forces the interface agent to rewrite the component and verifies it again before even presenting it to the human.
Wow. And what does that actually look like in practice? Do we have data on that?
We do. Look at the Fountain example from the data. So they are a frontline workforce management platform, and they implemented a hierarchical multi-agent orchestration system.
Okay.
They built a central co-pilot that coordinated specialized sub-agents to handle their whole onboarding process.
Yeah.
So one agent handled candidate screening, another generated the automated legal documents, and another analyzed candidate sentiment.
All at the exact same time.
At the exact same time.
So instead of a linear funnel where a candidate gets screened and then waits for a document and then waits for review, it just all happens instantly.
Exactly. They achieved 50% faster screening and doubled their candidate conversions.
Doubled. That's huge.
Yeah. In one specific instance highlighted in the report, they took a logistics customer and cut the time required to fully staff a brand new fulfillment center from several weeks down to less than 72 hours.
Less than 72 hours to staff an entire fulfillment center.
It's unbelievable.
That just drastically changes the economics of running a business. But applying some logic here, if these multi-agent systems are moving at machine speed in parallel, producing massive amounts of work over days, how do they not just compound their own errors 1,000 times faster?
That is the big question.
Right. Like if a sub-agent makes a mistake on minute 5, doesn't it just build a mountain of garbage by hour 10?
Well, what's fascinating here is how the architecture has actually evolved to handle exactly that. We are talking about the leap to long-running agents.
Long-running agents.
Yes, these agents are now managing the truly messy reality of software development. They plan, they iterate, and they refine across dozens of work sessions.
Over days.
Over days. And to your point about compounding errors, they avoid that because they can now maintain state.
Okay, maintaining state. For those of you who aren't software engineers, we should probably define that. It basically means the AI has object permanence.
Precisely. In older systems, if you close the chat window, the AI just forgot everything. It had amnesia.
Right, you had to start over.
Exactly. Maintaining state means the agent remembers why it made a specific architectural decision on Tuesday when it is fixing a downstream bug on Thursday. It retains the memory of its own logical pathway.
Here's where it gets really interesting, because that means it can learn from its mistakes.
Crucially, yes. This allows them to recover from their own failures. If a long-running agent tries a solution and the system throws an error, it doesn't just stop, wait for a human, and leave a mountain of garbage.
It figures it out.
It analyzes the error logs, adjusts its strategy, and tries a new approach entirely autonomously.
So the Rakuten example from the report illustrates this perfectly. They tasked an AI, specifically Claude Code, I think, with a highly complex mathematical extraction method.
Right.
But they didn't ask it to do this in some clean, modern, easily readable environment. They set it loose inside a massive open source library called VLLM.
And we should definitely clarify, VLLM isn't just a simple application. It's a foundational library used for running large language models.
It's massive.
Oh, it contains 12.5 million lines of code written across multiple different programming languages. The dependencies are just incredibly complex.
Yeah, for a human, just navigating 12.5 million lines of code to implement a mathematical change is a monumental, weeks-long task.
Oh, absolutely. Weeks, if not months.
Right. But the AI worked autonomously for 7 hours straight. And it didn't just write code. It mapped the dependencies, ran the tests, hit errors, backtracked, rewrote the logic, and finished the entire job in a single run.
And let's talk about the accuracy.
Right, with 99.9% numerical accuracy compared to the human reference method. 7 hours of uninterrupted, unsupervised work inside a code base, larger than most developers will ever see in their lifetime.
Which logically brings us to a collaboration paradox.
I know where you're going with this.
Right. If an AI can maintain state, recover from its own errors, and navigate 12.5 million lines of code to achieve near-perfect accuracy, what is the human actually doing?
Exactly. It really sounds like the human is just sitting back with their feet on the desk, drinking coffee, while the multi-agent brigade does literally everything.
It does sound like that, but Anthropic's internal studies revealed a really striking data point here. Developers report using AI in roughly 60% of their daily work.
Okay.
However, they report being able to fully delegate only 0 to 20% of their tasks.
Wait, they lean on the AI for 60% of their work, but only fully hand off 20%. Why?
It's a huge gap.
Yeah, if the AI is smart enough to navigate VLLM, why aren't they fully delegating more?
Well, if we connect this to the bigger picture, this paradox actually defines what vibe coding truly looks like. The AI isn't an autonomous replacement, it's a deeply integrated collaborator.
A collaborator, not a replacement.
Exactly. It attempts the work, but intelligent collaboration means the AI now knows its own limits. Sophisticated agents are programmed to recognize situations that require human judgment, and they flag that uncertainty.
So instead of blindly guessing at a structural problem and completely breaking the system, the executive chef basically pauses and asks the human owner for a decision.
Exactly. Human oversight is fundamentally shifting. It is moving away from reviewing every single line of syntax to reviewing what actually matters.
Which is the strategy.
Right. Humans are reviewing the edge cases, the novel situations, and the areas where business impact is most critical. You use the AI for things that are logically verifiable, but you keep the conceptually difficult design decisions for yourself.
That makes a lot of sense, especially when you look at the CR8 example. Because CR80 is a massive fintech platform in India, they're dealing with over 15 million users.
Right.
Obviously, in financial services, security isn't just a priority, it's existential. You literally cannot afford to let an AI hallucinate a cryptographic protocol into your banking app.
Oh, absolutely not. The regulatory and security risks are just way too high.
But they still implemented this AI system across their entire development lifecycle, and they doubled their execution speed.
And they did it by leaning into that collaboration paradox. They didn't eliminate human verification.
Right. They just shifted their developers away from manually typing out database queries and toward rigorous verification and high-value architectural design.
Exactly. The humans are still deeply involved. They're just doing the high-stakes critical thinking.
Right.
And this downstream effect, shifting from manual syntax to strategic logic, it's causing the fundamental barrier to entry in software creation to just crumble.
Because you just need to know what you want.
Exactly. If coding is increasingly about delegation, reasoning, and plain English constraints, you no longer need a computer science degree to build functional software.
Right. And if you're listening to this and you run a small business or maybe manage a non-technical team, you're probably thinking, well, this sounds great for a massive fintech company, but I can't afford a multi-agent AI architecture.
Right, which is fair.
But the data shows This democratization is happening everywhere, specifically around what the report calls paper cuts.
Paper cuts are a fascinating economic reality of software.
Let's explain those.
So these are the minor quality of life bugs. Think of like a clunky drop-down menu, a slightly misaligned button on mobile, or a missing export feature.
The things that drive users crazy.
Yes, they irritate users every single day, but previously they just weren't worth the economic cost to fix.
Right, because if an engineer costs the company
The $100 an hour.
exactly $100 an hour, and it takes them 3 hours of digging through code to fix a drop-down menu, management is just going to say, don't bother, we have bigger features to build.
Exactly. It's economically unviable.
But when an AI can analyze the code base and fix that paper cut in 5 seconds for a fraction of a cent, well, the economics of software maintenance completely flip.
Suddenly, the non-technical experts, the customer service reps, the marketing managers who actually use the software every day, they can just prompt the AI to fix the issues themselves.
Without ever filing an IT ticket or waiting on an engineering sprint, that is incredible.
Yeah.
And the democratization data is staggering here. Zapier rolled out agents internally and hit an 89% AI adoption rate across their entire company.
89%.
Yeah. Their non-technical design teams are now using AI to rapidly prototype functional design concepts live while they are literally on video calls with customers.
It's amazing. And look at Anthropic's own legal team. People with zero coding experience built self-service triage workflows that drop their marketing review turnaround time from 3 days down to 24 hours.
And TELUS shipped 13,000 custom AI solutions, saving 500,000 hours of work. So what does this all mean for the broader landscape?
Well, it means profound empowerment. But we really cannot look at this without addressing the sobering reality of what the security industry calls the dual-use risk.
Right, the dark side.
Unfortunately, yes. The exact same multi-agent architectures that democratize software creation also democratize destruction.
Because a tool doesn't have a moral compass,
Yeah.
it just executes the plain English constraints you give it.
Exactly. With these improved agents, a non-technical manager can act as a security expert, commanding an AI to perform in-depth vulnerability reviews and harden systems, which is great.
Ah.
But threat actors have access to these exact same capabilities. A lone hacker no longer has to manually probe a company's firewall for days.
They just use a multi-agent team.
Right. They can spawn a virtual multi-agent department of offensive AI, working in parallel to scale attacks at machine speed.
Wow!
They can coordinate phishing agents, network scanning agents, and payload agents all simultaneously.
That is terrifying.
The pace of autonomous threats is accelerating exponentially. The balance of power in the future will heavily favor organizations that bake agentic cyber defenses into their architecture from the very start. Because if you are trying to defend against a multi-agent swarm using only human security analysts, you've already lost.
So, synthesizing this entire journey for you, we are witnessing a tectonic mechanical shift.
You really are.
We've moved from single sequential AI agents that process one thought at a time on a tiny desk to parallel multi-agent kitchen brigades that can tackle entire departments worth of work simultaneously.
Working in parallel.
Exactly. And because of this structural shift, task horizons have expanded from an AI helping you for a few minutes to an AI working autonomously for days, maintaining its own state and recovering from its own failures.
Yeah.
And through it all, the human role hasn't disappeared. It has elevated from manual typing to strategic orchestration level vibe coding.
And the stakes outlined in this report's final warning are critical for anyone listening. The gap between early adopters and late movers is widening at an astonishing pace. Organizations that look at these AI agents as just an incremental productivity tool, treating them like a slightly faster version of autocorrect, well, they're playing a game with outdated rules. This is a fundamental reimagining of how humans and machines collaborate to solve complex problems.
Which leaves us with one final lingering question for you to ponder. We've talked about how the barrier between people who code and people who don't is completely disappearing.
Right.
But if anyone can create software instantly using plain English, what happens to the very definition of a software application?
That is the million-dollar question.
Will we soon enter a world where you don't go to an app store to download a pre-made generalized calendar or budget tracker?
Oh, wow.
Right. Will you just describe your highly specific temporary problem to your device, have an AI team build a bespoke, perfect application for you to use for exactly 10 minutes, and then delete it forever once the task is done? When you don't have to spend months building the scaffolding anymore,
Maybe you don't even need the software to be permanent.
Think about that.